Okay, I noticed someone asked argument. Okay, just now argument is a part of I didn't notice just now, so I explained. Okay, you see, argument is here, inside here. This is argument. When you have a function, you have to tell me what are the input and what are the output. Output is return type. Okay, return type. Arguments are input, so inside here. Okay, so when you do the function declaration, right, you must have both. What is the return value? What is the return value? What is the argument? You can have one argument, you can have more than one argument. For example, you see this function, right? Cons. Can you see this? This one got two argument, list and item. Okay, there are sorry, element. List and element, two arguments and one return type. So list is written. You understand or not? So this is how you read. Okay. So same thing. Like this one, head is a function. Head is a function. In this function, you have one argument and return is in the form of element. That's how you read. Okay. So this is a brief description about what you're going to perform in this particular, what do you call that, algebraic expression. Okay. Then this is what you import. So later you can only use integer data type. You cannot use any other data type because you only imported integer. That's the meaning. And you're going to use a sort which type. Data type is list. You can only use list. So you're using list or element of list. You cannot use any other new mathematical notation because you didn't import. You understand or not? Then same thing goes to here. Okay, this one I told you, right? The initialization. So the initial value, okay, of the length, okay, sorry, the initial value of the length is 0. So 0 start, initial value start with 0. That is the declaration, initialization, or you can even put some validation. Okay, if you want to put some validation like this value cannot be more than this value has to be this. All those things will come under axioms. Is that okay? But don't worry, you won't be learning algebraic any further. You will use model base. Okay? They look almost the same. Here you use more on list, head, element, tail, and all that. You learn data structure, right? If you take data structure, you will find it very easy to understand. Okay? After taking data structure. Okay, now, sorry. Okay, I think I've covered all this. Yeah, you know, right? When you declare a function, there can be a constructor, okay, destructor, or other operation function. So that's what I explained here. Okay, next, continue. Yeah, that's all for algebraic. Now we're going to go into model base. Okay, for model base, I choose Z schema to explain as an example. So everything is in the form of schema. Everything is in the form of schema. So let me introduce to you how schema look like. Okay, this is a schema. Okay, the Z schema. That's why the name is Z schema because we are using Z notation now. Okay, the name of the schema, okay, is here. The name. Okay, then as same like just now, the signature is here. Okay, so what is signature just now? Signature is the functions definition, the functions definition. So same here. All the signation will be here. So basically, I can say the definition of functions or the definition, the declaration of the variables. Here you can put variable declaration. You can put function definition. You can put both. Again, variable declaration and function definition. For example, the capacity must be a natural number. The capacity must be a natural number. The contents must be a natural number. The contents cannot be more than capacity. You have this much of capacity, so you cannot deliver more than what you have. So this is all the validation you can put under the predicate, all the conditions. Another word is all the condition. Okay, so the content must be less than equals to capacity. So you have any condition that cannot be what do you call that misrule, then you have to put here first, so that throughout the operations, right, this one must be satisfied. So can be precondition or post-condition. All the condition must be here. This one, all the declaration. Just remember as declaration. Signature is declaration. Predicate is all the conditions. Okay. Okay. We're going to learn how to write what do you call that formal specification for this system. Let me go through the system quickly. Then I show you how to write. Okay. So I have here pump. You know the pump which will induce insulin to, or release the insulin to the patient. Then I have a controller which control everything. Okay, I have a controller which control everything. Okay, then this controller, okay, has a clock so that the timer will be there for the medicine to be released to the patient. Okay, and there's a sensor to detect the glucose level in the human body. So this is like implanted device, implant into human body to monitor the blood, monitor the glucose level in the blood, and then when the glucose level is too low or too high or whatever, what medicine, like, the pump release insulin. This is for diabetic patients. So high glucose level. If the glucose level go higher, then it will calculate the dosage to be released to the patient body based on the patient's glucose level. This is for serious patient. They have this device. If goes slightly higher, can really kill the human. So that's why I have to monitor very closely to check if the glucose level is, like, abnormal. Automatically controller detect, okay, and then when come to certain time, it will, like, for example, 2 o'clock, release how much of dosage, calculate, and then the alarm will indicate that glucose is already released, a glucose insulin is already released to your body. Then the pump will reduce. What the pump will induce into the body. So the leader will implement that. Okay, so this is basic system, a simple system, but it is a critical system. Okay, now who can explain what is critical system? I give you 2 minutes to find out what is critical system. Okay, sorry for the disturbance. Okay, okay, now continue. I asked you to understand this, right? Okay, now we're going to write schema for this. Okay, using Z schema for what model base. Okay, so first of all, what are the three things you need to prepare? Okay, the name of the schema. Okay, then you have to have the signature, which is declaration. Then you have to have your condition. Okay, now this one shows you all the declaration. All the first of all, before you start with the declaration, right? We need to come up with state variable. State variable is to identify the data type. You don't declare first, but you identify the data type. For example, the reading must be from glucose level sensor. The dose, cumulative dose, there are two types of dose. Okay, this are reading 1, reading 2, reading 0, reading 1, reading 2 must be last 3 glucose reading. What is capacity? So you basically explain what are they. You introduce your variables first. Introduce your variable. Okay, then your input lah basically. Okay. After introducing that, okay, this is how we introduce. Okay, this is called state variables. Okay, you need to come up with the list of variable to be used in the system. Okay, after done with this, right? So you can have a look. Like reading is a natural language. This question mark is to show the data type, followed by the data type. The question mark is for input or output. Exclamation mark for input or output. What do you think? Reading is input. So a question mark is input. Okay. Exclamation mark is output. Display. Okay. This is display. This is reading. Okay. Input. You ask this from user. This one you display to the screen. Understand or not? So input and output. After done with that, okay. Now you have to see each schema, right? You must have a predicate which is condition. Okay, to show that what is allowed, what is not allowed throughout the operation. So now let's go to the next one. So your conditions all comes here. Okay, predicate. For example, the dose display must be less than insulin available. Yeah, you want to show that you're going to induce. Okay, let's say I don't know. For example, 0.5 milliliter dose, but you must make sure that is there enough stock in the device or not. If the stock is not enough, you cannot display this. You cannot display because there's no dose, so there's no enough what do you call that, capacity. So how can you induce this? Cannot. So the dosage is only displayed when you have enough capacity. Insulin available is always must be less than the capacity. So this is how you come up with all the precondition. This is N symbol. You know, right? N symbol. Capacity equals to 100 and safe minimum equals to 6 and safe maximum equals to 14. So the total, the capacity is always 14. That's what they are trying to say. Okay. Maximum daily dose, 25 and maximum single dose equals to 4 minimum single dose. So you know what is the meaning of this or not? Maximum dose can go up to 25. Minimum dose can be only 4. Okay, for a patient. One time release. Okay, this is how. Display always in a string. Okay, can understand so far? Okay. Don't worry, I don't ask you to write. This one is another course. But I have to teach you all the possible notation for requirement engineering. So this is one of the notation. Okay. Okay, now let's say we read some requirement and then we see how to write this, okay, in mathematical notation. The insulin pump computes the amount of insulin required by comparing the current reading with two previous reading. Okay, so basically you want to compute the amount of insulin, how much of insulin need to be released to the patient based on the two previous reading. Meaning, you have already two reading, right? Based on that reading, you calculate how much medicine to be released to the patient body. If this suggests the blood glucose is rising, then insulin is delivered. Yeah, meaning the glucose, you show that an increment in the glucose level, then time for you to release the insulin. Information about the total dose delivered is maintained to allow the safety check of total amount of insulin cannot exceed the maximum glucose per day. The one like Panadol, for example, you can take 2 every time. You can go for 4 times maximum, but one day you can only take 8. So you must make sure how many times you take also cannot more than 8 in a day. That's an example. So no need to repeat the dosage computation. Okay, now continue. If the dosage is the same as your previous dosage, you don't have to calculate again. Okay, this is run schema. Run the calculation and what execution. So now you have to carry out how to calculate the insulin and release to the what the patient's body. Okay, so switch auto. This is what I say just now. Input. Okay, so either on or off. Okay, status running versus running union status equals to warning. Okay, insulin available must be greater than maximum single dose. You want to release this single dose, you must make sure you have available insulin, sufficient insulin to release. Cumulative dose cannot be more than daily maximum dose. This one all done. And now you can perform your operation. This is operation now. Okay, so composed dose equals to 0. Okay, so dose cannot be cannot be 0. Dose cannot be 0. Okay, and now the maximum daily dose would exceed if the computed dose was delivered. What do you call that? So the insulin dose is set to difference between the maximum allowed daily dose and the cumulative dose delivered so far. So how much already delivered and what is the maximum for daily minus that is the amount allowed for this round. Okay, now you already take 2 times the medicine. So the third round, when you calculate, you have to make sure that it is between the maximum amount. After you minus the first 2 dosage, what is the remaining amount, maximum remaining amount can be taken for the day. Because you have maximum for every day one. So you cannot go more than that. Then based on that, you calculate. That's how you calculate like this. So you show how, this is a requirement, You don't explain in sentence, you don't show in diagram, but you are giving me in mathematical equations. You understand or not? This is what explained here. So what do you call that? Dose and cumulative dose plus this 2 must be greater than maximum daily dose. Must be greater than maximum daily dose. Not must. If this is greater than maximum daily dose, then the alarm will be played. The alarm will be activated, and what happened? Warning message will be displayed on the screen. You know why? The dose to be delivered and the cumulative, how much you have taken so far for the day, and this round dosage plus total dosage for the day more than maximum allowed dosage for the day, then alarm is displayed. Alarm is activated. So that's how you do. Okay. So your maximum dosage minus cumulative dosage is the dosage allowed for this round. Cannot go more than that. Okay. So that's the meaning. Can you understand? Okay, now we have done the run. Okay, so continue with the run. Okay, next operation. Next operation. The normal situation, if maximum single dose is not exceeded, the delivery or deliver the computed dose. Okay, if this situation is now fine, your dosage is below the maximum dosage per day, then calculate how much to deliver for today. So this is the calculation. So there's a formula to calculate how much to deliver today. So this is how you calculate. Okay. So any question? This is all for the system to execute to monitor the monitor the glucose level in the body for a diabetic patient. Any question? This is what you're going to learn. Your assignment, you need to do exactly like this. You need to think of a critical system to come up with a requirement. Okay, now tell me, can you use the title you have proposed for my SRE? Cannot. To do your formal method, what requirement specification? Cannot. What do you think? Do you think you are allowed to use the
Yes.
formal? Can. Actually, for our university students, we don't want to trouble you. You can use back my title. That's one advantage. You can use back my title for continuing your formal specification. Usually, we collaborate. Ponazu will allow my title because you already know clear requirement in my course. So you don't have to waste time to analyze the requirement again. Just that you have the requirement now, you need to start writing the requirement using formal specification. You just apply the formal specification. That's one advantage. Disadvantage by right, formal specification we don't simply use for ticket booking system, hotel booking system, food ordering system. All this we don't use formal specification. Waste of money. I told you what, it's very expensive. It's very, very costly compared to other two notations approaches. So what we do, we always use formal specification in our real life projects, right? If it is only critical, so who can define what is critical? Critical system, either life critical or environment critical. Anyone? You only use formal specification for a project which is critical. So if you look at my tutorial question, right, I have one question. Discuss a scenario for where a project scenario where formal specification can be applied. So if you go and explain your assignment title like ticket booking system, food ordering system, or sales point of sale system, you don't get any marks. You have to make sure you show a system which really need to be using formal specification, because that one you can still go for diagrammatic or natural language can be done and it is very reasonable. They are not risky system, they are not critical system. Critical means when the system error, a minor error can threaten the life or environment. For example, the user can, if let's say something goes wrong, it can kill the user who is using the system, like chemical monitoring system, flight controlling system. Now this one, patient, any medical related system which deal with what patient's life, car braking system, the airbag doesn't come out on time. Okay, any system that dealing with pollution detector. What happened to the environment? When radiation, you want to monitor the radiation in a certain place. All these are something to do with environment or user safety, right? Human safety. Then you can propose mathematical notation. Otherwise, don't waste your time. Okay, this is for my exam. Okay, my exam, when I ask for an example, never ever write any ordering system or mobile application which got nothing or no critical element. If no critical element, I cannot give you marks. It's not necessary to use some formal specification. You can go for natural language. You can go for what do you call that, diagrammatic approach. You don't have to use formal specification. You only give me example which is really critical. For example, like the other example in my lecture notes, door opening, door monitoring in a moving train. That is, if anything happen, a small technical error, what happened? Patient can what mean an accident, can kill a patient or can injure the patient. That is critical system. Any system that is critical, you can give as an example. But don't worry, when you take formal specification next semester or the coming semester, you can use back the title of your assignment because we don't really trouble you so much. We don't have much time to really go and analyze again. You can use back the what do you call that title. But in real case, we don't use formal specification for non-critical system. Waste of money. Okay, that's my conclusion. Understand or not? Okay, right? So in exam, must know how to come up with a critical system in case I ask you to give example of system where you can apply formal specification. So what is critical? If anything goes wrong, an error in the system can harm the human life or the user's life or can affect the environment. That is critical system. Okay. Okay. Now, what are the advantages of formal specification? Reduce the number of errors. Early stage, reduce the errors, and also errors or fault. Okay. Number two, cost effective. These are the advantages. Okay. Okay, now specifying quality requirement. Like I always say, a requirement must be always testable. If you go and write a requirement like availability, the system must be available 24 hours in a day. Is it measurable? Is that measurable? Available 20 hours. And first of all, is it practical? You won't have maintenance in the system. Won't have any downtime in the system. So your requirement always must be testable and also practical. So now, how can you write availability or maybe reliability? The system shall be available at least 95% every weekdays or weekend. If you have different timing for weekdays and weekend, then you can write like this. Or daily. You can just put daily. Exclude your maintenance hour from 3 to 5. So meaning these 2 hours are not included in the calculation of 95%. So these 2 hours are confirm fixed for maintenance. So the remaining hours are you must fulfill 95% of availability. If your system fail to always down and user use and the percentage lower than 95, then your system doesn't achieve availability. That's how you write. Okay, interoperability, testable. See whether your requirement either measurable or testable. Okay, must be either measurable or testable. So the chemical tracking system shall be able to import any valid chemical structure from the. So you can give a try. Later, use different version and see whether the system can accept or not. The system can accept if you use different type of version. If can, then testable. Yeah, pass. This requirement pass. So every requirement, if you read, you be there as a tester. Put yourself as a tester and read the requirement now. See whether you can test the requirement or not. If you can test, the requirement is perfect. Non-functional requirement or quality requirement always must be testable. You know what? My master project something to do with this. Okay, security. How to write? I always see students say the security of the system must be very high. The system must be able to protect the data. Wrong. Cannot give you any marks if you write like this. How to know whether the system is not protecting or not protecting? That requirement is not testable. The system shall log user account after like your Oracle. Oracle see user account after 4 consecutive unsuccessful logon. So when you try to simply go and input 4 times invalid details, right? Your username and password. See whether the system get locked or not. If get locked, yeah, pass security. So you have to come up with each and every requirement which is measurable. Understand or not? See, all these are measurable or testable. Otherwise, your answers are not acceptable. Remember that. A few more examples. Efficiency. Okay. At least 30% of the processor capacity memory available shall be unused. So later, you see how many percentage unused and calculate and see. You understand or not? During the peak hours. If it's already touched that 30%, then your system is not efficient. You can calculate. You can test. Okay? This also can test how many parts are, let's say you have 100 classes in your code. How many classes can be reused? You can calculate the percentage and see how many percentage managed to reuse. You understand or not? Each and every requirement I've given here are testable, measurable. So that's how you write from now onwards. If your requirement document got any general requirement or any untestable requirement, you don't get your marks. You don't get A. Get very minimum marks. Okay. Okay. What is quality trade-off? Okay. Quality trade-off. When you are trying to pay attention on one of the quality, you will be affecting the other quality. For example, for example, there is security and performance. Okay, so when you try to pay attention on the security, for example, you want to improve the security. You say, okay, I want multi-level security. For example, first I want what validation of login username and password. Then I want the what image identification. Then I want OTP. You because you worried your system information like very private and confidential can be hacked or can be leaked. So you want like more secure system. So multi-level security. Okay. So multi-level login authentication. So no problem. But what happened to the performance? And then somewhere else you say the performance of the system must be very high. This is problem. You want good security, but what happened to your performance when you increase the security? Your performance will be affected negatively. Meaning you increase the security, right? Sorry here. You increase the security. When you do a lot of checking, it is time consuming. How can you expect the system to give you the output in so quick response time? Short response time, not possible. So when you pay attention on one of the quality, you have to sacrifice the other quality. So that's the meaning of trade-off. Trade-off sometimes very lucky, you improve one quality, automatically another quality also get better. You improve the efficiency, right? Performance also something to do with time, what? So you improve the time, response time, performance gets better. So both also improve automatically, but sometimes unfortunately when you pay attention on one of the quality, the other one affected negatively. So you cannot be expecting for both to be improved. Is that clear? Okay. Sorry. Last one. Guideline for writing excellent requirement. Always be clear whether you are writing the requirement from system perspective or user perspective. Don't get confused. If you write from system perspective, like system validate the input. If user perspective, user enter the input and the system it will be validated. The information will be validated by the system. So include. Okay. For example, you draw a line. Enter the details. User enter the details, and then the system validate the information entered. So that is include function. So you have to be very clear whether your requirements is written from user perspective or system perspective. Don't mix up both. Cannot, not allowed. Of course, when you cover the user perspective, the system perspective will be ignored. Okay. So you have to give me two different component. One is system perspective, one is user perspective. So system perspective, you have to write, okay, what the each user perform, what each user perform. For the system perspective, different table or different listing, give me what happened in this module, what are the functions done by the system. You understand or not? So you have to separate. Okay. Don't put it together. You cannot put like you say, okay, this is the user, like chemist. This is the user. Then suddenly I see the system validate the value entered. Now you see the requirements are the chemist, but you go and put the system perspective. Not proper. It's not wrong, but mix up. The document is not in correct format. Okay, not well structured. Writing style. Make sure your requirements are written in a good style, correct style. Okay, like shall, the optionality or mandatory. For example, shall is mandatory. May or can or should is optional. So you need to specify that. Avoid what amalgamation. Do not have and or in the requirement or comma. Not allowed. I always see student now the midterm also. Wait, I feel like coughing a bit. Okay, in the midterm, right? There's what borrow and return, right? I don't know why. I myself, I put it very clearly. Borrow is a function, return is another function. They don't share the same step. How come you go and write one use case, borrow or return? Why you so lazy to separate into two use case? If you put one use case, the answer is not acceptable because amalgamation. You have two requirements in single statement, which is wrong. So individual requirement in individual statement, one statement each. So you cannot use all this. Don't put avoid, unless, except. All this are also multi-requirement in one statement, which is wrong. You shouldn't have more than one requirement in one statement. Clear? Regardless, this requirement is very short, very simple, still one requirement, one statement. Final check before you submit later. Okay. Okay, and last one, last slide on the guideline, level of detail. This one, the most common mistake among students. You need to know whether you are going for the first level or second level or third level. Like now, I'm only asking for first level use case, but I notice some student in your use case you have include like five include, meaning your main function include four include one main function include four, and then still first level. But your included function include another four steps, no need. That is second level already. Did I ask for second level? If I ask for second level, I don't ask you to draw in the same use case. It has to be separate use case. So each of your include must be another use case. You understand or not? So break down further. That's how we draw. We don't put everything in one. Last time, student got do that. Even though I explained many times, student got do that. And then external examiner from University Malaya, the university I studied, came here, the professor, he asked, the students can see like their assignment work, always all the work will be moderated by someone, not from TAM. Someone external, a proper university will come and moderate. So this auditor said, this moderator, what we call, yeah, reviewer or moderator, will come and moderate. And he said, I can see like students still not really clear about the level of detail. So when you have a main use case, include something, okay, include A, include B, include C, include D, all four include in the main use case are correct. That is first level. If you want to show further, can. I don't say wrong, but it's not needed for this assignment. We only go for first level. But if you want to do many levels, everyone must follow the same. You understand or not? Usually, right, when you, okay, now your main use case include A, then the A include, let's say, P include X. You have further level, right? Usually, we put the A in another use case diagram to show what are the steps in A. You understand or not? Separate diagram. That's how we do by real. If you go and check all the reference book, it's supposed to be that way. So you don't have to show very detail now, which will be like very messy. Then the diagram, what is the advantage of diagram? What easy to understand, overview and structure quite clear compared to natural language. But when you do this right, it can become more complicated. You understand or not? That one you need to understand. It's not wrong, again, it's not wrong. But you don't have to mess up your diagram with so many levels. That's what I'm trying to say. So you must be very clear of what level are you doing. Okay? Representation of techniques. Okay, consider the most effective way to communicate with each other requirement. Okay, so what technique you want to use? Okay, so you have to be very clear on that. Don't have like lack of clarity. Try to not to have such requirement in your document. Finally, these are the things I will check later to give you marks. I cannot say your requirement is wrong. That is your assignment. That is what you analyze from your company, the company you have chosen. I cannot say your requirements are wrong. I can only check your document for these things. Writing style. Have you used a proper shall, may, whatever, wherever necessary? I check whether every requirement is individual requirement or not. I cannot say your requirement wrong. I got no right to say that's your requirement, your project. How can I simply say wrong? I can only check whether you are following the format, the guideline, the notation that I teach correctly or not. Okay, so that's why I call it as verification. Okay, so level of detail, I check how many of you understand. You cannot show different levels in one. If too many levels, that will affect your marks very little, but don't worry, it will affect very little. Okay, representation of technique. What technique have you used? Consistent or not? Ambiguous, any ambiguous requirement. I don't understand what you are trying to say. Out. All the requirement. You say this module is my module. Okay, have you identified all the basic? For example, you say account management. If I don't see reset password or recover password, out. You have username and password is your login method. How come when someone forget the password, there's no way for him to recover? Or at least admin reset the password or anything to reset, recover the password. If nothing, incomplete requirement. If important requirements are missing, incomplete. Sometimes students do login but no logout. All this happened before, just tell you. Understand or not? So that's why we check in your requirement document. We don't say your requirement wrong. There's no wrong, right? It's your project. You analyze. You are the developer. It's your idea. I cannot say your idea is wrong. That's why we don't need reference for part 2, 3, 4, 5. No reference needed. Why? Because you are not referring anything. There's no any. You are just following whatever you learn to come up with your requirement document. You apply. So when you analyze, I see how well you are able to analyze. That's determine your marks. Understand? So this will give you more experience to do your final year project later. Okay, I think that's all. I'm so sorry So sorry to make the class online. I'm having fever, so I don't want to spread to the others. I'm on MC, and I don't want to. Yeah, I see the attendance better, so I also happy. But I cannot do online, not allowed. Now I'm doing because I have MC, so I'm just doing online. So I treat it as extra class. Okay. So because if I cancel this class, imagine I cannot finish my syllabus already. No, I can finish, but I cannot do revision. So next week I want one class for revision. So I cannot do that. So I don't want this to happen. So that's why I'm doing today. So today I covered chapter 5. Unfortunately, the talk made me extend my chapter 5. But the talk was very useful. You can try to think of that for your final year project. Software engineering student, you need to have something related to AI, automated improvement, refinement. If you just develop another system which is already there in the market, thousands of systems, you just come up with another system. We are not testing your skill. Your skill is tested in every assignment and coursework. We are testing on your idea of producing your own project. So you must come up with something interesting, refined, modified. You take an algorithm A available. You take an algorithm B. You already have two algorithms invented by someone. You just use that and come up with another system. You cannot get A. This two algorithm you try to merge, or you try to make changes to one aspect, improve, and then you test and see whether results improving or not. That is good research value is there. So that's what we are expecting from RSW students. So that's why the talk I find it very useful for you, but I don't know how many of you really paid attention. So I don't feel bad for using my time for the talk, but it's okay. Okay, any question you may ask now. Raise hand. Yeah, any question? You guys have any question before you submit the assignment? My groups will submit tonight. What about the others? Already submitted? 5 o'clock or 12 o'clock? It depends on the tutor again. It depends on the tutor. My students need to submit by today. By today, 11:59. Okay? Okay, alright. You guys, please submit a good assignment. Still have how many hours? Wow, not bad. You have more or less can you help us mark attendance? Yeah, I mark the attendance, but I will take time to do it. You know why? Only 224 present. So 97 absent. 98 absent. 98 absent. Okay. How many? 322 or 321? I cannot remember. So 90 something absent. So I need to check who is absent. So I'll mark your attendance. Don't worry. Okay. Whoever cannot mark your attendance yourself, don't worry. I'll mark based on this attendance. Okay. So that's why I have the record here, so I can mark. Okay. So I'll mark by today, tonight. Okay. Okay. I think I am having 6 hours class continuously. Monday is the most number of classes. So I'll take a break. Then I mark later. Okay. Thank you. See you. Bye bye.